I just want to go through the booklet for Patterns and Relations Part 2. So this is your to-do sheet for this week. You have your mental math as usual. Make sure you hand that in to me. And then you have a student guide. It has a little Mario on the front. This you keep at home in your math binder, but do complete everything in it. Okay. So the coordinate grid system, I believe you guys have done some things in the past where you had to plot points on a coordinate grid. So this first section is just a review. So this being your horizontal or x-axes, this being your vertical or your y-axes, and we always go this way first and then up. So my little color coding, if you were going to this point A, then we would go over 5 and up 3. And we always start from the origin. The origin is always at 0, 0. Okay, and then when we have coordinates that are very large, then we can actually play around with the scale. The most important thing is that every jump along one of your axes needs to be worth the same. So you couldn't start 2 up and then go 5, 6, 7, 8 because this first jump was not worth 1. So as long as each one is worth the same value, you have a consistent scale and you can change them. So if we're trying to figure out the coordinates for B, it looks like we go over 2 and up 6. However, we have to see what they're worth. So really the value is that we went 10 to the right and we went 30 up. So the coordinate would be at 10, 30. So you always have to look at what the value is when you plot points. So then there is an exercise here. Again, there's an answer booklet that has all of the answers for this. Don't worry about if you used a different scale on your axes. Don't worry about that because that's perfectly acceptable as long as you're using a consistent scale. It should still look similar. So give that a mark. Make sure that if you have any questions as you're working through it, that you are contacting me. Once you're done, there's only 3 questions on this try it out section, but I do want you to complete your mystery coordinate design and then hand that in. There's a few people got a few different ones. So how this works is there's a whole bunch of instructions for different points to plot. So you would plot these ordered pairs or these coordinates, and then you would connect them all. So connect them with a straight line, and once you stop, then that's one section. So then you wouldn't connect this point to this point. So these are all connected, then that group will be all connected. So like I said, there's a few different ones out there, and I believe in your answer booklet, I included what the mystery picture should look like. So if you think you're off to the wrong start, then just check it out and see how you're doing. So why did I review plotting points? Well, because when we're representing patterns, we can represent it graphically. So this is a pattern that's represented visually, so with pictures, and we can actually notice what's happening. We would be able to probably draw the next figure by following that pattern. What we can do is we can take a pattern and we can turn it into a table of values or an input-output table. So figure 1 is your input, and the number of tiles it had was 3. Figure 2 had 5 tiles, and then you could keep going like this. From a table of values, we can write the expression. So remembering that to get your multiplier, to get that 2, it's whatever your increase in your output is. So if it's increasing by 2 each time, that's your multiplier. to figure out what this second value is, we just plug it in. So if I took this 3 and I times it by 2, then I'm at 6. I need to get to 7, so I had to add 1. So then you try it here. 4 times 2 is 8. Add 1 to get to 9. So that's how I knew that it had to be add 1. If you're still confused about how to come up with the expression or the rule for the table, then make sure that you're contacting me and I'll try and give you a few extra examples. Okay, so the cool part about a table of values is that you can graph any table of values, and then you can look and see what the graph would look like. So if we kind of color coded it just to kind of show you back to what is an input doing. These are all your input values. These were all the output values. They have to link to whatever was on the table with them. So 1 was with 3, 2 was with 5, etc. So the input is your horizontal movement. So remember the Mario figure is that he runs first and then he jumps. The output would be your vertical. So input, we run, output, we jump. So then we can plot all of them on a graph. Now, sometimes the tricky part is coming up with the scale for them. You don't want to just pick the scale that you see here. You want to actually pick a consistent value to go up by. So this right here is going to be graphing the pattern. So you want a title. So this one was talking about the number of tiles in a pattern. Going along your x-axis, it's labeled of what it's talking about. So if it was just the input, you would just put the word input, but these are actually talking about the figure number. And then your vertical axis was talking about the number of tiles. So in figure 1, there were 3 tiles. Figure 2, there were 5 tiles. Figure 3, there were 7 tiles, and so on. So step 1 is to make sure that you have your titles and that you label your grid and that you use an appropriate scale. Step 2 was to plot those points. Step 3 is, well, I guess really make sure that it's labeled. I guess step 1 and step 3 are very similar. Conclusions are really just discussing what pattern you see on your graph. So we can see that each time the figure number increases by 1, the number of tiles increases by 2. So that is the relationship that the graph is showing us. Okay, and then I included one more example because sometimes it's tricky to wrap our head around it. So this one's just a basic input-output table. So if you look at the graph, I actually labeled it input, output. We always start at 0. This scale is different. Every square is actually a value of 2. So even though these aren't all multiples of 2, that's fine. They will fit somewhere on my graph. So I labeled the coordinate grid. I plotted my points, and I didn't add a title because there's not really a title for this. I guess we could call it input-output pattern. But when we look at what the relationship is showing on the graph, as your input increases by 1, your output's increasing by 3. So even though it looks like it only increased by 1.5, it increased by a value of 3. So that's important. So you've got a few questions to work through. Blank graphs, so you're going to have to write your own scales for them. Again, check the answer booklet. I'm hoping that that's helpful for you. And then the back has a few extra questions. So again, keep this at home when you're done working through it. Keep the answer booklet at home when you're done working through it. Then on day 3, you're going to do crack the code, which is this page here. And basically all of the letters are assigned a value from 1 to 26. And then those would be kind of like your position numbers or your input numbers. And then these 2 friends, they created a machine or a rule for changing them into a code number. So they applied a rule to each of them, and then it went through the washing machine, but this is what they saw that was left, and they had to recreate, figure out what that pattern rule was again. So this one, I want you to try and complete the table and fill in what you think the code numbers would be for the first few letters. Then try and write the expression for that table. So what is their code rule? And then this is the message that they wrote to each other. So you're going to decode it to see what the message says. And then another one of the friends replied with a mystery picture. So plot the points to figure out what the mystery picture was. And then create your own code. So using the same inputs as before, so the 1 to 26 as your inputs, come up with a rule, create a code, and then write me a message with the code numbers, and then give me like a A, B, C, D, or any 4 letters that you want, and tell me what their code number is, and then I'm going to try and crack your code. I guess if you give me the first 4 letters, that would be too easy. So give me some hard ones, see if I can crack your code. Hand this page in at the end of the week, as well as the review booklet. So when you hand in things, I want to see your review booklet, I want to see your crack the code, and I'd love to see your mystery coordinate design, because those are just fun to watch. So if you have any questions, make sure that you contact me. You guys, if you have access to Zoom, I did put in a Battleship grid. That's for the Zoom class. So just make sure that you bring that to our Zoom class, and we'll do a little activity with it.